This is the proof of the combinations formula. Let n and k be integers such that n is greater than k and k is greater than or equal to 0. Prove that n choose k plus n choose k plus 1 equals n plus 1 choose k plus 1. The first thing is we need to know the formula for n choose k, which is n factorial over k factorial times n minus k factorial. We proceed to solve for the left-hand side of the equation. We have this left-hand side of the equation here, which is n choose k plus n choose k plus 1. We identify n choose k, which is n factorial over k factorial times n minus k factorial, and we identify n choose k plus 1. Let's do it. N choose k plus 1 is n factorial over k plus 1 factorial, k plus 1 is our k, times n minus k plus 1 be inside the parentheses, n minus parentheses k plus 1, close the parentheses, factorial, equals n factorial over k plus 1 factorial. Now we distribute the negative and we have n minus k minus 1 factorial. We put together the left-hand side of the equation and we have n choose k plus n choose k plus 1 equal n factorial over k factorial times n minus k factorial plus n factorial over k plus 1 factorial times n minus k minus 1 factorial. Now, we need to find a common denominator to solve this addition because we have fractions here. We have to find a common denominator in order to solve it. So how do we find a common denominator? Well, what is it that we don't have here that we have in this part of the addition? Well, in here, we need a k plus 1. We have a k plus 1 here, we need it here. So we're going to multiply times k plus 1 in the numerator and denominator, which we have here, n factorial times k plus 1 over k factorial times n minus k factorial times k plus 1. We already have now the k plus 1 that we needed. But now in this part of the equation, we have k plus 1 factorial, but we don't have n minus k factorial. So what do? Again, we multiply in the numerator and the denominator by n minus k, which is what we need. So we say n factorial times n minus k over k plus 1 factorial times n minus k times n minus k minus 1 factorial. Now, what is k plus 1 times k factorial? That is the same as k plus 1 factorial. What is n minus k times n minus k minus 1 factorial? Well, that is the same as n minus k factorial. And as you can see, we have the same denominator in both fractions. Now, we can solve the addition. So we are left with n factorial times k plus 1 plus n factorial times n minus k over the common denominator, which is k plus 1 factorial times n minus k factorial. In the numerator, we have a common factor. We factor it out, which is n factorial, times k plus 1 plus n minus k over the k plus 1 factorial times n minus k factorial. But in here, k minus k, positive and negative k, they cancel each other. So we are left with n plus 1 times n factorial over the k plus 1 factorial times n minus k factorial. But what is n plus 1 times n factorial? That is the same as n plus 1 factorial right here. So we are left with n plus 1 factorial over k plus 1 factorial times n minus k factorial. Now that we have solved the left-hand side of the equation, we'll go to the right-hand side. The right-hand side of our equation is n plus 1, choose k plus 1, which is equal to n plus 1 factorial on the numerator over k plus 1 factorial times n plus 1 minus k plus 1 factorial. In the next step, we're going to distribute this negative times k and times 1. So we have n plus 1 factorial over k plus 1 factorial times n plus 1 minus k minus 1 factorial. This plus 1 and this negative 1 cancel each other. 1 minus 1 is 0. So we are left with n plus 1 factorial over k plus 1 factorial times n minus k factorial, which, as you can see, is the same that we obtained in the left-hand side of the equation. So we have as a conclusion that the left-hand side of the equation equals n plus 1 factorial over k plus 1 factorial times n minus k factorial, which is the same that we obtained in the right-hand side of the equation. Therefore, n choose k plus n choose k plus 1 equals n plus 1 choose k plus 1. And we have proved the combinations formula.